Hello, this is Assignment 1, Introduction to Machine Learning. I'm Nikita Igorov, and I will be briefly going over the code that was provided. So once we import the data, we can get a general feel of it by looking at the rows, looking at the info about the data. We can look at the counts for some of the variables, like this categorical one. And we can also find valuable information about the numeric variables by using the describe function, right? We could see the count, mean, standard deviation, and so on of all these different variables, different categories, sorry. We can then plot it. We can make histograms for each of the columns to see the distribution, see how skewed the data is, and so on. Then we need to use our data to make a training set and a testing set. We can use a random split, which we do here, and we can see that the random split is quite representative of the actual population, obviously, given that it's 80% of the actual population. But there's a problem with that, and the problem is that the random split does not preserve ratios. We are aware that the median income has a really high impact on the median house value. So we want to make sure that the ratios of the different incomes are the same in the original population as well as the training and testing sets. So that is very difficult to do since median income is a continuous variable. So what we end up doing is we make it a discrete variable by binning the different incomes into these 5 separate categories. Now that we have these 5 separate categories, we can use the stratified shuffle split to create a training set and a testing set that will preserve these ratios. We can then get rid of the discrete median income as it will not be useful any longer. We can then plot a bunch of graphs that get increasingly more descriptive with the more parameters that we add, this last one being the most descriptive. Here, I had to drop the ocean proximity from a copy of housing, as the correlation matrix does not work with non-numerical data. Ocean proximity will be processed later. So here we can see the different correlation values for the other categories and median house value, with median income being very highly correlated, while, for example, population is not very correlated. Next, we can plot all these different correlations to get a general feel about them. This is income versus house value. You can see that it shows a strong correlation, strong positive correlation. Now we can add some combined attributes to our data sets, and we can see how they are correlated. And in fact, we could see that bedrooms per room is relatively strongly correlated with median house value, while simply bedrooms or total bedrooms is not. Then we have an issue to solve. So some of our categories are missing data. In particular, I think it is number of bedrooms. So what we're going to do is we're going to use a simple imputer to replace any missing data with the median value for that category. We end up training the imputer on our data and then using the imputer on that same data. Now our housing trained has all the missing data filled in. Next, we need to deal with ocean proximity. Since it's a categorical variable, we need to change it in a way that the machine learning algorithms are able to use it. One of the ways we can do that is we can either use the ordinal encoder or the one-hot encoder. In the end, they assign a value to each of these string categories and give you that. For an ordinal encoder, it is a value from 1 to however many, from 0 to however many categories there are. And a one-hot encoder will actually give you a sparse matrix, like this. You can look at it as an array. So whatever works better for your model. Then we will implement some transformers. This transformer will add combined attributes to our data, similar to what we were doing before, just this time it is much easier and can be reused. So we will add rooms per household and population per household, with bedrooms per room being an optional input. Now we will create a pipeline so that all of our transformers can be called from within one function call. So this pipeline will include this simple imputer, the combined attributes adder, and also a standard scaler to scale our data so that it's easier to work with. Next, we will use a column transformer. This will allow us to apply transformers to both the numerical and categorical data, so that the numerical data will receive this number pipeline and the categorical data will receive the one hot encoder. Now we can attempt a few models for our data. The first model we try is the simple linear regression. After training, we see that there's quite some differences in the predictions and the actual labels, and we see that the mean squared error for it is really high. The linear regression is unable to train well on the data, unable to predict it well. What we can use instead is we can use a decision tree regressor, a much more powerful model, which actually after training will give us a 0 mean squared error. This is also not good, as now the model is overfitting and will not be able to generalize well. Thank you.